Hi guys, I wanted to do a brief video that explained a little bit more about finding instantaneous velocity through a position graph. Remember that position graphs are going to tell us where an object is relative to the origin at any given time. So, for example, maybe I have a position graph that looks something like this. What this position graph is telling me is that my object starts off when time is equal to 0 at about 1, 2, 3, 4, and a little, we'll call it 4.3 meters. And then the object increases in its position until it hits a maximum position right here at time t equals 1, 2, 3, 4, 5, 6, 7, 8 seconds. Right? And the maximum position that it reaches is 5, 6, 7 meters. So here's the maximum position. Then the object turns around and it starts going backwards. So all the way up here at t equals 20 seconds, it is at the origin once again. Okay, so that's how we understand the motion of the particle. First it's going forwards until it hits a maximum at t equals 8 seconds, and then it goes backwards. And now we ask the question, well, what can we say about the velocity of the particle that's moving at different times? So let's pick a time at random. Let's say time t equals 4. What is the velocity of the particle at time t equals 4? So to find that velocity, I'm going to go over to the graph and draw for myself a line that touches the graph at a single point. Move this down a little bit. Touches the graph at a single point and goes in the same direction as the graph. In other words, has the same slope as the graph at that point. Now there's going to be a little bit of subjective difference of opinion between different people's tangent lines. So somebody might draw a tangent line a little bit more like this at t equals 4. And some people might draw a tangent line that is a little bit more or less slopey right there. So drawing the tangent line only gives us an approximate answer. But once I have drawn the tangent line, the slope of tangent to the xt graph is the velocity at that time. In other words, because this line is tangent at t equals 4, its slope will give me the velocity at t equals 4. And to find the slope, now that I have drawn the line, I can pick a couple of points on the graph on the line, maybe here and maybe here. And this point is 0, 3. And this point is 8, 7. And I can find that slope in the usual way. So the slope, which is the velocity, and again, the slope, which is the velocity at 4, is going to be equal to rise over 1, or 7 minus 3 meters for every 8 minus 0 seconds, or 4 over 8, or 0.5 meters per second. And it's the velocity, so we'll give it a nice plus sign. The plus sign on the velocity, the positive velocity, indicates that the particle is moving forward. So this is one of the important things about velocity, and that is that if velocity is positive, then the object is moving in the forward direction, whatever direction that is in your reference frame. Now let's consider a different time. Maybe time t equals 10. And we ask, what is the velocity at t equals 10? So we go over to t equals 10. And this is our position right here, and we draw ourselves a tangent line, one tangent to the curve, like so. And this looks like a pretty good tangent. Now that we've drawn that tangent line, we can pick a couple of points on the tangent line. This point is 14, 16, comma 3. And this point right here is the point 6, comma 9. Just like that. And so the velocity at 10 would be equal to the slope of this line, which is going to be rise over run, or 3 minus 6, over, 3 minus 9 meters, 3 minus 9 meters, over 16 minus 6 seconds, which gives me negative 0.60 meters per second. And here, the negative sign indicates that the object is moving backwards, which we knew already. The object is moving backwards for every time on the portion of the curve that is in blue. So here we have the velocity that is less than 0, and the object is moving backwards. Now there's one special point on our velocity graph, and you may have already thought about this, but right here, where the red portion of the graph and the blue portion of the graph meet, right at that point the object stops moving forward and starts moving backwards. And to do that, the velocity has to become 0. And sure enough, if I draw a line tangent to the graph at the top of this curve, at the maximum point in the curve, then you can see that the slope of that line is 0. So right here at t equals 8, the velocity at 8 is equal to 0, the slope of the line. And that indicates that the object is stopped. So there are two things that I want you to take away from this. The first is simply how to compute velocity at a point. And the answer is draw a tangent line at that point, find its slope. The slope of the xt graph is the velocity. The second thing that I want you to see is that a positive slope indicates that the object is moving forward, and a negative slope indicates that the object is moving backwards, and a 0 slope indicates that the object is stopped at that time. And in particular, once you get used to that idea, you can very quickly look at a position versus time graph and figure out when the object is moving forward or backwards. So let's make up a crazy graph. Maybe my object is moving with a position versus time that looks like this. And I ask a simple question. When is the object moving forwards? And the answer will be whenever the slope of the graph is positive. And that would be from here up to here. That would be from here up to here. That would be from here up to here. And looks like that's it. That would be all the times for which the graph is increasing or has a positive slope. Likewise, the object will be moving backwards whenever the slope is negative. And that would be from here down to here, from here down to here, from here, all the way down to here. Anytime the graph of the position is decreasing or has a negative slope. And finally, the object will be stopped at any point where the slope is 0, and that's going to be at the points where the position locally has a maximum value. Well, I hope this was helpful to you, and I'll see you in class tomorrow.